welcome to another tutorial / demonstration of the Nios II softcore processor. This time we are going to be adding demonstrating interrupts in the Nios II. We're going to do that by adding a interval timer that will interrupt at a specific time, and then we'll write a interrupt service routine that will handle that. So let's get started. First of all, we bring up Quartus and we do a new project wizard. We'll go ahead and hit next, and we'll go pop this out into my video demo folder, and we'll just create a new folder. We'll call this Hello Nios INTR for interrupts. Call the project the same thing, and we are the 5 CSX FC6 D6 F31 C6. That's our chip, and we'll select Quest Intel FPGA. So once our project is created, we'll go ahead and fire up Platform Designer so we can start designing our softcore system. Alright, so we'll go ahead and maximize that window, and like always, first things first, we need a processor, right? So we'll go grab a Nios II. And for now, I'm just going to leave the defaults and take the /F version. We need some on-chip memory. And I want a little bit more than 4K, so I'm going to go ahead and just add a 0 and give me 40K. We need a JTAG UART. And for this one, I'm just going to go ahead and take all of the defaults. And then in order to demonstrate the interrupt, we're going to add one we haven't played with yet, and that's the interval timer. So we'll go ahead and add that interval timer. With the interval timer, we have lots of things we can set. I'm going to go ahead and set this interval to 500 milliseconds, so every half second. I should be fairly fast, but not too slow, not too fast for the text stream to keep up. Don't really need to change anything else for this, so we'll just go ahead and hit finish. Alright, we now have all of our components, so we need to get all this wired up. Like always, our debug reset request is going to go up here, and then we wire up clock and reset to all of our peripherals. Alright, and now the on-chip memory gets both data and instruction masters. The rest just get the data master. And this time we have 2 interrupts we need to wire up. So we're going to wire up the timer. Well, let's just wire them up in order. So we'll do that one, and then we'll do that one. You'll notice it automatically assigned the JTAG UART to 0 and the timer to 1. I want to change that, so I'm going to make that one a 0, and I'm going to make that one a 1, because the lower the interrupt number, the higher the priority, and I want the timer to be the highest one. So we'll just call this timer. We'll call this debug. We'll call this our SRAM, and we'll call this our Nios INTR for Nios interrupts. That's pretty much it for wiring, so we can just assign our base addresses. That gets rid of everything but our last 2, and we can get rid of those by assigning our vectors to our SRAM. And there we go. And like always, since I'm just demonstrating a processor today, if I save my Platform Designer project as the same name as my top level, then I don't have to do an instantiation template. INTR. Let's get that right. So once we are saved here, I will go ahead and I will hit that Generate HDL button, and I'll just take the defaults. Alright, our HDL generated successfully, so I can go ahead and hit close and finish. And of course, as soon as I do that, Quartus is going to say, hey, you did a bunch of new IP, you should probably bring that in. So we'll do that. We'll go over here to our files interface and we'll say add. And we'll go into our Hello Nios interrupt folder in our synthesis, and we'll grab that quip file. And go back to hierarchy. And now I just need to do a analysis and elaboration, or what I like to call a quick compile, so that we can extract the pins and assign the pins before we do our full compile or full elaboration. Okay, we can now go over to our assignments and our pin planner. And we only have the clock, and if you've watched any of my previous videos, we know that's on pin AF14. We can double check that by looking in the user manual. And yes, clock 50 is indeed pin AF14. So there we go. I can close that, and we can go ahead and start our compilation. And in the meantime, we'll go ahead and hit Tools and bring up our Nios II software build tools for Eclipse. That way we can get started on the software portion, because our software portion is going to be pretty big for this one. We got a lot of code to write. We'll go ahead and hit Browse here, and we want to go to our Hello Nios interrupts, make a new folder. We'll call this one Software. And that's what we'll use for our workspace. Alright, we now have Eclipse open, and we'll go ahead and maximize that. It's just about done being set up here. There we go. We can do a File, New, Nios II Application, and BSB from Template. And we got to go grab our SOPC info file. Alright, we know we have our right processor because it says Nios interrupts. We'll just name this Nios Hello Nios INTR. Choose our Hello World small, and I can go ahead and hit finish. Alright, our projects are created. Like always, before I mess with anything, I like to do a build. So I'm going to go ahead and start a build on the project. Okay, everything built okay, so I can go ahead and open up my Hello World Small, and I'm just going to hit Control A and delete. Okay, I've got my empty Hello World Small now. We need to go grab a couple of files out of our BSP. We need the system.h, obviously, and we need under drivers, include, we need the timerregs.h, and then under how, might be under source. Alright, it's under how include sys. We need to grab the altera alt underscore irq.h files. Those are all the files we're going to have to include. And we'll show you what we need to grab out of each one of those. So let's go back here. Let's just put in a little header block just for fun. Alright, so this is example of interrupts using timer. Okay, so first off, we need to do a pound include. We're going to use standard io.h. Then we need to do a pound include our system.h. we need to do a pound include. It's sys/alt irq.h because it was in the sys folder. We need to do a pound include Altera Avalon, helps if you can type, timer regs.h. So those are the 4 header files I need to bring in. Now we're going to bring in some function declarations. So first we're going to have a void. I'm going to have a function for initting the timer. And it takes a void. And then we're going to have the actual ISR, so we'll make that one static. Void timer ISR. And it's got a very particular format it's got to follow, which is a void star context, and then a Altera unsigned 32-bit ID. Then we need main. All right. So first off, let's go write those 2 functions. So we'll start with that init timer. It's got to do a couple of things. We need to register the ISR with HAL. And the second thing we need to do is start the timer. Okay, so registering the ISR with HAL, there's a function we call, and it's in the alt IRQ. So we'll just search for it here real quick. It is alt IC ISR register. So here we go, that's the function, and you can see it takes the ID, the IRQ, the pointer to the function, the context, and then any flags. So we'll go over here and I'll just paste that in. And we'll go get those things in order. First, we need the timer from system.h. We need to go down to the timer definitions. So here's the timer definitions. So we need to find the one that says timer IRQ interrupt controller ID. So we'll copy that, and that's what goes in that first spot. Then we need to know what the IRQ number is, which will just be timer IRQ. So we'll hit Control C there and Control V. And then we need our function. So we'll cast that as a void star. And our function is timer ISR. As far as the rest, I'm just going to put null. I don't care about a context. And, oops, not period, comma, and I'm going to send no flag, 0x0. So that will register our ISR with the system. Next part is to start the timer. To do that, I need to look at the Altera Avalon timer regs, and I need to look for the control register. So I want to do an IO write to the control register. So I'm going to hit Control C on that, and again it takes base and data. So I'll hit Control V, and there we go. We'll go grab the base out of system.h, That's the timer base. And then also in the regs file, we have all of our masks, right? So I want to make the timer continuous. So I'm going to grab that continuous mask. I'm going to OR that with, I want to start the timer, so I need the start mask. And I'm going to OR that with, oops, I didn't want to do that. There we go. I need the interrupt mask, the ITO mask, to turn on the interrupt. So we'll put that in there. So those are the three things I need. And I'm just going to make this look a little prettier. There we go. So that's that function. Now let's go down and write the actual interrupt service routine. For the interrupt service routine, I'm just going to do something really silly. I'm going to do a static int count and initialize it to 0. Next, we need to clear the interrupt. And then do something. And the do something, we'll go ahead and do that. We're just going to do a printf /n timer expired %b and do a count ++. So we're just going to print out every time. We're going to keep a count of how many times the timer expires and then print it out, which is really kind of, you know, not what you really should be doing in an interrupt, but it works for demonstration purposes. So how do we clear the interrupt? Well, we need to go back to that timer regs, and this time we need to look down for the Avalon, Altera Avalon timer status reg, and we're going to do a write. So we need to look for an IO write to the Avalon timer status register. So I will go grab that. And again, we need to give it the base. So the base is the same thing we used before. It's timer base. And then I just need to write a 0, right? I need to clear the flag for the interrupt, which is just writing a 0 to the flag. It's pretty simple, pretty straightforward. So that is my two functions. Now we need to go back and write main. Let's just do some silliness, printf. Hello from Nios II, our standard little thing that we've been doing. /n printf this is an interrupt example using an interval timer with interrupts. Sounds good. Okay, so now we need to enable the timer. So that's just calling our function, right? So init timer interrupt. That's pretty simple. And everything else happens in the ISR. So while 1, right? And then, of course, we need our return 0, even though we'll never hit it, because main says it's returning an int. So there we go. We should now be able to build this, make sure we don't have any errors. All right, looks like we have a problem. We have an error someplace. It's not liking something here. I probably messed something up. Multiple markers at this line, timer ISR. Oh, oops. Timer ISR, not time ISR. There we go. Let's save that and try compiling again. All right, it looks like we were a lot happier that time. So we can go back and check on Quartus. It should be done with our compile, which it is. So we can go ahead and program up our chip. We'll hit the programmer. We'll just do a quick save so we can save our setup here. Again, we'll do a quick save, and we'll go ahead and we can watch it program the board here. Go ahead and hit start, and there we go. Board is programmed. So now we can go back to our Nios, or our Eclipse, and let's create a run configuration. New. All right, we'll call it Nios INTR. We'll go to our target connection. Hit our refresh, hit apply, and then just go ahead and hit run. All right, we're downloading to the Nios. There we go, and there we go, right? Hello from Nios II. And about every half second, we should be seeing timer expired and the count go up, and that's about what we're seeing. I don't have a stopwatch to check exact, but looks pretty good. So that concludes our demonstration / tutorial on using interrupts with a Nios II processor.